Dear students, this gives me a different experience to stand before you to present this video lecture. And in our classroom, we discussed about organometallic catalysts. There are two types of catalysts. Number one, homogeneous catalysts, and number two, heterogeneous catalysts. Organometallic catalysts usually comes under the category homogeneous catalysts. So homogeneous catalysts means both the reactants and the catalyst are dissolved or present in the same phase. So if both the catalyst and the reactant are in the liquid phase, then it is considered as a homogeneous catalyst. Let us begin with the first example, that is called as a Wilkinson catalyst. So this is Wilkinson's catalyst, a rhodium based organometallic complex. In this compound, you see there is one chlorine ligand and the other three are triphenyl phosphate ligand. So the IUPAC name is chlorido tris triphenyl phosphine rhodium 1. So this catalyst is used in the hydrogenation of alkenes. So you know that alkenes have a double bond, and hydrogen means addition of hydrogen. So when hydrogen adds to alkene, it gives an alkane. For this reaction, we need a catalyst. That catalyst is called as Wilkinson's catalyst. So I do not want to take much of your time. I try to explain this concept or the steps involved in the action of a Wilkinson catalyst as much early as possible. So this catalyst actually act in 5 steps. There are 5 steps in the mechanism of this catalyst. Step 1 is the dissociation of the ligand. In the catalyst, we have 3 triphenyl phosphate ligand. They are very big ligands. So in the first step, one of the ligand gets dissociated. That means one of the ligand is lost. For simplicity, I put L for each triphenyl phosphate ligand. So here, you look, one ligand gets dissociated, and in that place, a S comes and coordinated. S means the solvent that is usually present in the mixture. So in the first step, one of the ligand gets dissociated and the solvent gets coordinated. Step 2 is the oxidative addition. In the second step, the hydrogen molecule gets added with our rhodium atom. Here you look, there are 4 ligands, the coordination number is 4, and now here the coordination number changes to 5. Our solvent leaves and the hydrogen gets dissociated and adds with the rhodium. Here you see the coordination number changes to 5 from 4. So therefore we call this as addition. And again, why this is called as oxidative addition means the catalyst, the oxidative state of rhodium is +1, but after the addition takes place, the oxidation state changes to +3. So oxidative addition means increase in the oxidation state as well as increase in the oxidation number. Step 3 is the coordination of alkene. This is the crucial step and is the rate determining step. Now what happens here in this step is, again, the alkene gets coordinated to the rhodium atom, that is coordinated to the metal through its double bond. Next step is migratory insertion step or migratory insertion reaction. You know the meaning of migration, that means change of position. Look here, that is hydrogen that is directly attached with the metal rhodium, but when you comes to the other side, that is the product side, the position of hydrogen gets changed, and where it goes, it gets inserted between this carbon and hydrogen. In the step 4 starts with one hydrogen which is attached to rhodium, but it is migrates from its position and inserted between the carbon and hydrogen present in the alkene, and we get the product like this. Now the alkene changed to alkyl group. The final step is reductive elimination. So elimination means some group is going to be eliminated, and reduction means so far the oxidation number of rhodium is +3, and in the final step again the oxidation step changes to +1. Here the coordination number, you see 1, 2, 3, 4, 5, 6. 6 is the coordination number, and after the step is completed, coordination number changes to 4. So in conclusion, in the final step, the reductive elimination means oxidation state also changes, coordination number also changes, and we get the product here. See, in the final step, again we regenerate the catalyst which is present in the first step. So, the first step, this is the catalyst, this is the active part of the catalyst which is also regenerated in the final step, and this process goes continuously. So, after this fifth step, step 1, step 2, step 3, step 4 and step 5 all goes in a cycle.